Hello, my name is Lena, and today I will be talking about the Ideomotor principle as a human-robot communication method during collaborative work. The ideomotor principle refers to all those unconscious cues that are manifested in human body language during the process of interaction and that contain valuable information complementing speech. We chose to focus on this because we believe an interaction method that closely adheres to the principles underlying human communication is the one that is most likely to succeed. This concept is sometimes also referred to as the clever hands effect after the work published by Oskar Funz, a German psychologist who studied the topic. In analyzing the potential of these cues as a communication method during collaborative work instances with a machine, we wanted to verify three main points. First, would it reduce the cognitive demand of a robot operation on the user? Second, would it positively impact work performance, especially in terms of would it allow to have both parties fully autonomous within that collaboration instead of a user constantly supervising a robot? And finally, would it allow a two-way communication with a single method as the machine and user both communicate through behavior? We divide our analysis into two steps. First, we want to see if cues used by a machine would hold the same amount of information or be perceived the same way by the individual collaborating with the robot. We did that by picking a task and analyzing body language cues that were positively impacting the quality of the collaboration between two individuals. We programmed the robot to mimic these cues and use them similarly to how we had noticed an individual would, essentially to mimic human behavior. We then had participants perform the same task, but this time in collaboration with the robot. The second step of our analysis consisted in seeing whether an artificial agent would be able to identify these cues as manifestation of user intention. The goal was to have a robot capable of identifying different cues and associate them with the appropriate command. We had 4 different tasks. Each participant was asked to perform each task, first voicing the commands to establish cue and command association without having the user actively translate their intention to specific predefined motions. Participants then performed the same task, but this time without using any form of explicit communication with the robot. For the first part of our analysis, with the machine communicating with its user by mimicking the implicit cues, results show that participants were much more comfortable collaborating with the artificial intelligence when the cues were used. The overall impression was that it allowed people to be less anxious about sharing a workspace with the machine. They also had this idea they could focus their full attention on the task and didn't fear sudden and unexpected behavior from the robot. And this result, of course, translated by a significant work performance improvement in our quantitative analysis. For the second experiment, we gathered evidence showing that the design model was able to identify different cues and associate them with the correct command, resulting in a robot capable of behaving according to the user intentions without explicitly being told what to do and despite a change in context. When looking at the ease of use of the method, we realized that as participants became familiar with communicating with the robot using implicit methods, they found it much easier and less demanding than explicit methods such as speech and voicing instructions, partly because they no longer needed to memorize the different commands. Findings comforted us in the idea that a sustainable human-machine collaboration method, or at least communication method, would be one that closely relates to the process of interpersonal communication. And this concludes our work. Thank you.